So we're going to start by taking a look at the last problem out of last night's assignment. And if you did a little bit of plotting and scheming and a little planning, a little bit of a strategy there on last night's assignment, you might have thought to do the same. You might have thought to start with this last one because everything that assignment was to the fourth, basically. And so if you'd done this first, then you could have applied that to a couple of the other problems at the same time. And so in order to find this derivative, now first of all, remember what this really means here. When I see g of x to the fourth, really that means that I'm doing g times g times g times g. And in order to find that derivative, there were multiple strategies that people used. Some people just went from scratch. So it basically said, okay, well, out of this whole thing, I see that I could break it up into two pieces like that. And then I'm going to use product rule. And when I use product rule, I'm going to have to use product rule within product rule for each of these. And you can do it. That'd be the long way in my mind. But I think there's an easier way to do it. Because, of course, if I'm going to be doing g times g times g times g, that is the same thing as doing g squared times g squared. Now, why would that be helpful? Because we already figured out what the derivative of g squared was yesterday in class. You actually could do the same thing as well if you had done it as g times g cubed, because we also figured out the derivative of g cubed yesterday. But I'm going to go ahead and use the g squared. So let's take a look at how that would look. So the first thing I'm doing is I'm just thinking of this as g of x squared times g of x squared. And actually, I'm going to go back. I'm going to change the color of that so we can keep track about which one's which. G of x squared. All right, so I'm now going to go ahead and find my derivative. So I need to use product rule here. So I'm going to do original times derivative. So my original here is this g of x squared. And I now need to multiply that by the derivative of the g of x squared. And again, that's one of those that we did yesterday. So if I just look back at my notes from yesterday, I could see that that's going to give me 2g of x g prime of x. So that's just from what I did yesterday, all right? Then from there, I'm going to do plus, because I'm still in the midst of using product rule. And I'm now going to do derivative times original. So I'm going to do the derivative of that first g of x squared. So that's going to give me another 2g of x g prime of x. And then times the original. So then that's going to be times the g of x squared. So I just used the stuff that I had from yesterday. You could have done the same thing, like I said, with g times g cubed, or you will still get to the same place if you did it the long way. All right, so now I'm just at the point where I need to clean this up a little bit. Now, of course, both of them ended up being the same, right? Both of these include the g of x squared and the 2g of x g prime of x. So because of that, I can now combine those. So each of them is 2 times something. So that means I'm going to have a total of 4. Actually, let's go ahead and stick with that. 4 times that something. Now, in each of those terms, how many g of x's do I have multiplied out together? 3 of them, because I have the g squared times the g. So that means that I have a g cubed sitting in here. So I'm going to do g of x cubed times the g prime that's left behind. So then that's times g prime of x. And there we have our derivative. And we have our rule now for any function to the power of 4. It's going to be 4 times the function cubed times the derivative of the function. Now make sure you have this written down correctly, because this is going to relate to a rule we get here very shortly. But also, it's going to help to do problems that look like this, because now this problem is much, much easier. Instead of having to now go through and do this the long way, I can jump straight to my derivative here. Actually, before I do the derivative, I do want to write it out one other way, just because I really want to make sure that we see this. Because the sine and cosines, those to a power, sometimes mess with our heads. Remember that this is the same as this. Okay, when we have that fourth power in the middle like that, it really means that the whole sine of x is to the power of 4. So we need to remember that. If that sometimes throws you off, start by writing it down like that. It's going to help you keep that straight. All right, now let's go and find our derivative. The pi, of course, is just going to stay a pi. And now I multiply that by 4 times my function, sine of x in this case, cubed times the derivative of my function. And the derivative of sine is cosine. How do I know that this is my derivative? Because I just did it on the last one. Just instead of writing g of x, I'm writing sine of x. Last thing I do here is just clean it up a little bit. So y prime here would equal 4 pi sine cubed of x cosine of x. And there, we're done. Next up, for this one, well, I did throw you one problem in there that would be a bit of a curveball on that assignment, where you could look at going about doing this one the same way with using the fourth, but you really don't have to. In fact, that would actually make it quite a lot harder. I would start by simplifying this. And so I'm just going to take this and turn it into f of x equals, first of all, I can pull out that root 3 as its own, but then I'm doing the square root of x to the 4th. What is the square root of x to the 4th? X squared, yeah. And so this is just root 3 times x squared. Well, now I can find the derivative of that just using power rule. I don't need to do anything else fancy. So I don't want us to forget that we can make this simple on ourselves sometimes. We don't have to make things overcomplicated. All right, so to find my derivative now, f prime of x is going to be root 3 times 2x. And so f of x, therefore, is just 2 root 3 times x. Or you could write it as 2x root 3, which might be just that little bit cleaner if we want to be as proper as we can be. Now for this last one, at the moment this doesn't quite look as familiar, but of course it is function composition where I'm going to find the derivative of h, and that's defined as f of g of x. So let's start by just writing out what h of x is. So h of x here is going to be f of, so I'm just replacing the x with the g. So it's going to be 7 minus 5x to the 4th plus 13. And this now should look like your assignment. Number 3, actually, off of last night's assignment. This is the same problem now. Now, you got a couple options. You could go ahead and do 7 minus 5x to the 4th, multiplying all that out. Or we could use the rule that we came up with our g of x to the 4th. Which one seems easier right now? Well, everyone might be a little bit different with that, but for me, I don't really want to have to multiply that thing out to the 4th. So I'm going to use the rule where we wrote it at the start of class of the derivative of g to the 4th. So then, I'm going to do h prime of x. Actually, I'm going to go a little bit lower so I can have more room to write here. H prime of x equals 4 times the 7 minus 5x to the 3rd times the derivative of the 7 minus 5x. Well, what's the derivative of 7 minus 5x? Negative 5. All right, so that now is the derivative of that part of my function. I just have left the plus 13. What's the derivative of the 13? 0. So that goes away. So this is our derivative then. We just need to clean it up a little bit. So h prime of x equals, I can multiply the 4 by the negative 5, and so that would give me negative 20. And then I still have the 7 minus 5x cubed. Now, if you did it out the long way, you could go ahead and multiply out the 7 minus 5x cubed, and then multiply by the negative 20 to make sure that does give you the same thing. But I really don't want to be multiplying all that stuff out, so I'm not going to worry about it. All right, now for each of these problems, we've been using one very specific case of a function composition kind of problem with derivatives. And this problem is written this way, partly to help us see that. To see that we truly were plugging this equation into the other equation. All of these were, though, because like even the very first one we talked about, the g of x to the power of 4, that's a function composition, right? It's a composition of the g of x with like x to the 4th. So we're plugging a function within a function there. And we really don't want to have to do product rule for all of those, right? Like, I'll tell you, it will not be very long down the road here, and you're going to be asked to find the derivative of something that maybe is like f of x equals some polynomial, let's make one up, x minus 2, a nice simple one, but to the power of 100. We definitely do not want to be multiplying that out, right? You don't want to have to do product rule so many times, and you certainly don't want to be having to distribute that out and end up with 100 different terms in a polynomial. And so we need a better way to be able to go about it. Now you'll notice here that for all of these we are using that rule where we found that the derivative of g to the 4th was 4 times g cubed times g prime. You might have noticed that it's almost like you got a little bit of power rule in there, right? Because you'll notice that it started out as just g to the 4th, and so we took the 4 and we put it out front, and then we subtracted 1 from it to get my new exponent. It's just that it was not just 4g cubed, it was 4g cubed times g prime. As it turns out, this actually is a general rule that we could follow. So for instance, with this problem that I just made up over here, we could actually do that derivative by taking the 100 down out front, doing the same thing inside, and using power rule on that. It's just that we would then have to multiply it by the derivative of the inside. Well, the derivative of x minus 2 would actually just be 1, making it a lot easier. But we can do that. That sort of rule does work. And in fact, we can even do that with all the other rules that we know. This rule, where we have a function within a function, is called the chain rule. This needs to be added into your derivative rules page. And this is hardly the last one that we're going to be putting on the derivative rules. So if you need to go on to the next page, go on to the next page. Now the good news is that there really are 4 big derivative rules that we use all the time in order to find any derivatives, and really that allow us to find any derivatives. It's power rule, the very first one we learned, then product rule, then quotient rule, and then the 4th one that gets used all the time is this, chain rule. So by the time we've gotten used to this one, we're going to be able to find derivatives of basically anything. Now, it's not to say there aren't going to be other little rules and little nuanced ones and niches and all that kind of stuff, but these are the big ones that come up all the time. All right, so we're now going to practice using our chain rule today. We're going to start with these two, where we really need to be able to see the difference between what's playing the role of the inner function and what's playing the role of that outer function. So go ahead and write these two down, then we're going to find our derivatives together. Right, now when looking at this, we want to identify kind of what's the outer function and what's the inner function. So looking at this first one, my inner function is whatever's inside a cosine. It tends to be a little bit easier when it's sitting inside of something that looks like cosine like that. So now when I go to find my derivative, I'm going to do the derivative of the outer function. So that's going to be the derivative of cosine. What's the derivative of cosine? Negative sine. Now, notice in this case, though, we're not doing the derivative of cosine of x. We're doing the derivative of cosine of x to the 4th. So that gives me negative sine of x to the 4th. So that part stays exactly the same on the inside of that. So the inner function stays right there. And then we now multiply that by the derivative of the inner function. So what's the derivative of x to the 4th? 4x cubed. And so then that's my derivative. The last thing I'd do in this case is just clean it up a little bit. So if I clean this up, I want to have the negative 4 out front. I'd even put the x cubed out front. And then my sine of x to the 4th after that. Now looking at the second one here, again, we want to be able to figure out what's the inner function and what's the outer function. And I kind of alluded to a good way to go about this one earlier today when we were looking at the sine to the 4th. That a great way to start this one is actually just to rewrite it as cosine of x to the 4th, because that means the same thing, right? And so by writing it that way, it just makes it a little bit easier to tell what the inner function actually is. Because in this case, we can see that, unlike the last one, the cosine here is the inner function. All right, so now when I go to find my derivative, I'm going to do the derivative of the outer function first. So the outer function here is something to the 4th. It's a function to the 4th. And so that's going to give me 4 times that same something. And so it's going to be 4 times the cosine of x to the 3rd. So notice that's the derivative of something to the 4th. It gives me 4 times the same something to the 3rd. It's just that with chain rule, I then have to multiply that by the derivative of that inner function. So now I multiply that by the derivative of cosine, which of course is negative sine. So I'm going to multiply that then by negative sine, and notice it's cosine of x. So my derivative of cosine is negative sine of x as well. All right, and again, now we're just left to cleaning it up a little bit here. So I would just call it a negative 4. And it doesn't really matter which one we write first, the cosine or the sine. So I'm just going to go ahead and write the cosine first, and then my sine. This then is done. That's what we were looking for. So notice the difference between what's playing the role of the inner function, what's playing the role of the outer function, and how that relates back to the chain rule and how we got to put it all together. Once you get that part straightened out, chain rule goes pretty smooth, but usually it's just a matter of getting that part down. I'd like you to go ahead and try finding each of these two derivatives on your own before we do them together. The first thing you want to do when you do look at these is think about what's the inner function. So for instance, for this first one, your inner function is the 8x, your outer function is the secant. All right, so then I got to actually find that derivative. So I'm going to do the derivative of the outer function. So that's the derivative of secant. What's the derivative of secant? Secant tangent. Yeah. But it's not going to be secant of x, is it? And it's because it is secant tangent, but because that's secant of 8x, that 8x is actually going to follow it. So it's going to be secant of 8x and tangent also of 8x. Then I multiply that by the derivative of the inner function. And of course, the derivative of 8x is just 8. Now, for cleanup, about the only thing that we can do here is just write the 8 first. It's the only thing you would need to worry about. Otherwise, we got our derivative. And then for the second one, we normally would think of e to the x. I know the derivative of e to the x, but this is not e to the x, it's the e to the power of some other stuff. So that other stuff must be my inner function, as we would say. So this is the function within the other function. All right, so now when I go to start finding my derivative then, it's going to be derivative of the outer, so that's going to be the derivative of e to the power of anything. Well, of course, the derivative of e to anything is just itself, so it's going to be e to the power of the x squared. Actually, let's do that in the blue to remember that that's the inner function. X squared minus 4x plus 5. So you notice that that inner function doesn't change when we find the derivative of the outer. All right, so that's the derivative of the outer function. I now multiply that by the derivative of the inner function. So that's the derivative of our exponent in this case. So that's going to be 2x minus 4. And yeah, we could clean it up by writing the polynomial first maybe. You could even distribute the e in if you felt like it. We don't, strictly speaking, have to do any of those. I'm just going to go ahead and leave this one as it is, because that's fine for our derivative. All right, so with these, we've been seeing lots of different little variations with what happens with different functions plugged into each other. But some other weird stuff can happen where you can even plug a function into itself. You know, this is like the f of x kind of thing that you might remember from your function compositions. Well, we can find the derivative here just as well. No, it cannot be simplified in any other way. It's just going straight to finding the derivative. So do so, please. All right, so for finding this derivative, the nice part is that if you mixed up what was your inner function and what was your outer function, it probably wouldn't affect you too much, right? Because at least they both are signed. But of course, we just need to have the little details in there done correctly as we go through. So when we go to find our derivative here, y prime is going to equal derivative of the outer, so derivative of sine is cosine. But of course, it's not cosine of x here. It's cosine of the inner function. So it's going to be cosine of sine of x. Whatever was on the inside stays on the inside. I now multiply that by the derivative of the inner function. So the derivative of sine, that is cosine as well. So that's going to be cosine. But since I'm just now finding the derivative of sine, notice it's just of x. So it's cosine of x. And then, yeah, this is fine for your final answer. There's not really any way that we can simplify that. There's nothing magical about what cosine of sine equals or anything like that. So we're done here. All right, so for finding this derivative, again, thinking about what's the outer function, what's the inner function. In this case, my inner function is all of this stuff hanging out inside of the square root. So that means that my outer function is the square root function. That means I can now go to find my derivative. So, oh, by the way, one other little side note here. In case you were thinking about, well, I could turn this part into like root 5 times the square root of x cubed or something like that, and then do minus the square root of cosine. That does not work. Because of the subtraction being inside here, we cannot split that up like that. We can only split them up when it's multiplied. So if we only had the 5x cubed, yes, we could go into that. But because of that subtraction with the cosine, that means we cannot go there. All right, so back to our normally scheduled programming. All right, so we got our square root here. I want to take the derivative of square root. By now, you probably don't even need to turn it into x to the 1/2 and go from there. You probably just know that's always going to give me 1 over 2 times the square root. Just in this case, it's not going to be 2 times the square root of x. It's going to be 2 times the square root of 5x cubed minus cosine of x. Now, I said you probably can just go straight to this, but remember, if you can't, remember this ends up being that whole thing to the power of 1/2. And so I end up doing 1/2 times that whole thing to the power of negative 1/2, and then I turn it into that. Okay? All right. Then, I still am not done with this derivative, because I still have to multiply it by the derivative of the inner function. So, derivative of the inner function, I first do the derivative of 5x cubed, which will be 15x squared. And then minus the derivative of cosine, because it's a separate term, so I don't need to use product rule or anything like that. It's just take the derivative of each term. The derivative of cosine is negative sine. So my minus becomes a plus, and then it's sine of x. Now this one I would definitely want to clean up a little bit, because a fraction times something like that, much simpler, just write whatever it's being multiplied by as your numerator. And so it's 15x squared plus sine of x all over the 2 times the square root. That then is done.